Hello everyone, welcome to 2026. So I can see the hall is full of people. So thank you everyone for coming this session. So let's start our session. What an year we are facing, right, in the world of technology. Think about it. Few years ago, we amazed when AI writes a simple text or a simple paragraph. We amazed, right? We talk about that. Then explosion happened. ChatGPT took the world by storm. Now the AI is not just limited to the labs or research. Now it is in all of our hands. So in my point of view, 2023 is the year of awareness. 2024 is the year of experimentations. And 2025 is the year where enterprises took AI seriously. And 2026, what it can be. Any guesses or any points? So yeah, maybe it is the year human are going to handle the keys to the AI. We don't know. Let's see what happens. So in these days, you can see a lot of autonomous agents do a lot of things, right? They take in decisions, they build in workflows, they are dealing with customers. If you are building an AI agent, that is not just coding. It is that you are sharpening the future of how the business operates, right? So we are moving the concept of AI as a tool to AI as a teammate, right? But there is one thing: this whole excitement is come with challenges. I mean, real challenges. Let me show you what I'm going to say. So in this example, you can see the challenges we will find when we building the AI agents. So the story about this sample is like this. So nowadays, almost all the people are busy, right? I'm also busy. I think you guys are also busy. We haven't time to cook, right? We need convenience, so we don't like to cook. So what is the solution? Build an AI agent to do the kitchen stuff, right? So actually, a set of people did that. They build an AI agent to do the kitchen stuff for the human. So theoretically, it is very amazing, right? But let's see what happened when it go to the practical. So you saw that what happened. So like I said, theoretically it is amazing, but in practical, oops, it went fail. So what is the reason for that? Someone can guess? The reason is, in theory, in the demo, before that I need to say, I believe that it worked perfectly on their demo condition. It worked perfectly when they show that to their client, the demo, when they show that to client. But in the real conditions, in the real complexities, it failed. First one is real fire. It is not a simulated heat source anymore. And it's a real kitchen with different layouts that AI is hard to figure it out. And also real pan with the weight and physics, and also moreover, the slippery flow. I think that slippery flow is never they have thought about that. And that is why AI agent got failed and it failed. So like that, there are a lot of complexities. So it is very different in the AI domain. I need to say the demo you build, the prototype you build, if it is worked, if it is success, that doesn't mean that it worked on the real enterprise production. So ladies and gentlemen, I'm Sasindu Alahakoon, Senior Software Engineer at WSO2, and today I'm going to discuss about why successful AI prototypes or demos fail in the production. So let's start with this famous quote from the Andrew Ng. He said, all of AI has a proof of concept to production gap. So if you don't know about Andrew Ng, he is the co-founder of the Google Brain and Deep Learning AI, and he is a respectful figure in this AI domain. So this is not just a philosophical observation of him. There's a background story for that. What happened is, Andrew Ng and his team was assigned to build a AI model to determine pneumonia patients based on the X-ray images. So what they did is, they went to a hospital and analyzed the X-ray images, and they built a model. And actually it works well. Like the results are perfect. So they got very confident about their product, and they deployed it in another hospital in the same town. So surprisingly, the accuracy got reduced in that hospital. It failed. So then they confused why it is failed, because it worked on the previous hospital, right? The thing is, the X-ray image quality, the quality of that X-ray images is different in that hospital to that hospital, the first hospital to second hospital, and also X-ray image positioning is also different, and there are a lot of other other parameters also different between two hospitals. That's why that AI model got failed in the second hospital. So that is what this Andrew Ng mentioned about this gap, proof of concept to production gap. So let's visualize this gap. So in this image, you can see in the left hand side, we have AI demos. So normally AI demos are for validating the feasibility, right? Is this work? Can we do it? Something like that. We normally use clean data sets in our demos. So without less edge cases in our demo data sets. And also normally we run those on our local machines or basic virtual machines. But in the other side, in the enterprise production, it is totally different. It is not about is it work, right? It is about is this work with our customers? Is this work with our real data? And is it available to 24 hours in 7 days? And also, is it have a ROI value? That is the main question they ask when we going to deploy in the enterprise productions. And also in the enterprise productions, it is not clean data sets anymore. It has live streaming batch data with drifts and different edge cases. And also we deploy scalable clusters and containers. So AI demos are completely different from the enterprise production. And what is this bridge? That is the one we're talking about this session. So this bridge, we have to go through this bridge to build convert our successful AI demos to enterprise production. So in WSO2, we travel this bridge many times, and actually we build this bridge with our experience, with hard-won lessons and experience we gathered. We gather a lot of experience when we cross in this bridge, and we learn a lot of lessons in mostly hard way. So today I'm going to discuss about those lessons and what we learned when we convert our AI demos prototypes into real customer productions. So before going on forward, let's see how an enterprise AI agent looks like. So this is an actual sample that we worked on with our customer, high-level architecture of what we did for our customer. So in the first glance, you will see it is not that simple, right? It is not like we are just prompt something to ChatGPT and get an answer. It is not like we are just calling an API and get an answer. It is really complex. You can see the user interact with the internal website, and there's a backend server, and the backend server connect with the AI agent. After that, AI agent need to connect with this all service layers and third-party APIs. And AI agent is not just give and response. It need to coordinate with all these systems and all these ecosystems and coordinate that, communicate with that, and finally, AI agent need to give an answer. So that is the complexity in the real world enterprise AI agent system. So keep with that in mind. Let's continue. So beyond this slide, I'm going to share with you the hard-won lessons we learned while we working with our customers. So if you sleep or if you didn't listen in this session, your AI agent in the future, the AI agent you built will fail. So carefully listen and thanks me later. Okay, the first lesson, and in my point of view, this is the most hardest one and the most fascinating one. It works yesterday and now what? Nondeterminism. So you may heard this problem, but I experienced this problem with the real-time customer works. But in traditional softwares, if you talk about traditional softwares, they are predictable and they are deterministic, right? So if you give the same input again and again, it will produce the same output. So when we're dealing with customers, if the customer is relatively new to the AI, he or she expects the same behavior from our AI application. So, but AI is, probabilistic. It is non-deterministic. Same prompt does not guarantee the same output. You can see this in the picture. When I ask, tell me a joke, in the first place, it will give a real joke. And the second place, it will give another joke. Okay. But in the third place, what it gives is, I am afraid I cannot tell you a joke right now. So, contradict answers, right? So, imagine if this happened in a real customer environment. Like customer test the product one day and it produced, like our AI product will produce real answers and customer satisfied about that. He is very happy. And on the next day when he tried, it gave completely contradict answers. So what happened? It is support ticket, right? Maybe it's a critical support ticket, trust issue, like that. So we need to identify this issue. We need to know these things can happen and we need to find a solution while we are delivering AI applications. So when we are developing the customer real world enterprise products, these are the things we followed to, I would not say avoid, but reduce the non-deterministic behavior of the AI. Best practices are, we can use prompt engineering techniques to mitigate this non-determinism problem. We can instruct the LLM to, like, the response format, response constraints, and like response structure for its LLM's response. So we can give instruction to, like, you need to give the response in this format. You need to give the response with this structure, with these constraints, and with these rules. So it will help to that prompt engineering. After that, the prompt engineering will help to give some kind of a deterministic structure of the answer. And also context management, it is very important. I have a slide about context management in the upcoming slides. I will talk that. So if you don't know about what is context means the surrounding knowledge that LLM wants to, AI agent wants to give an answer. So correct context means correct answers, and incorrect context means inconsistent answers. So it is very important. And also, since AI are by design probabilistic, we need to implement fallback strategies as well. That can be a retry mechanism, or that can be another LLM call, whatever. We need to implement the fallback strategies as well. And also there are few parameters. If you know, you know. Otherwise you can learn. Like for the LLM, there are some parameters we can fine tune when we are developing AI agent. In the LLM model, there are few parameters. One interesting parameter is called temperature. So we can change this temperature parameter, and also there are top P, top K, those kind of parameters. We can change those parameters to change the behavior, like behavior of our AI agent. So if your customer wants deterministic, more constant answers, you need to use low temperatures, while your customer wants creative or variety of answers, we need to use high temperatures. And obviously testing and monitoring is needed. It is needed for every software, right? So what I would like to say is this thing. Don't see non-deterministic as a bug, because it is there, right? Architecture for it. Like embrace it as a feature and architecture it, so you can avoid the problems you will find in the production environment. Okay, the second problem. This is also a very common problem, and this is it runs on my machine problem, right? The classic problem. I think we all face that problem in some point of our life. It's work on my machine, but it is not working on your machine. But this is kind of a bit different. This is in AI context, but not enterprise scale. So in here what happened is, developer develop an AI agent. He plug a memory to the AI agent and he test it is perfectly work. So he confident about that. Then he scale that to the production and give to the customer. So after 1 or 2 weeks later, maybe 1 or 2 days, customer complained that AI agent is not working. It cannot memorize things. It don't know what I said earlier. And then developer get confused because it's work on his machine. But this is what happened. After we deployed, in practical world, the most commonly, we have few replicas of AI agents, right? So we have replica 1, replica 2, replica 3. So we can have a number of replicas. And there's a load balancer in front of them, and there's the user. So user don't know that there are how many replicas there are. He thinks that there's only one AI agent, but in the production, there are a lot of replicas. So if the memory is, if there's a local memory, I mean, if the replica, each replica contains each separate memory, what happens is, if the first request go to the replica 1, then yeah, it will put that into the memory that the username is Alice. But if the second request go to the replica 2, then it does not know what is the name of the user. So this is happen like if you not architect your AI agent properly into the production scale. So the solution is, there are a lot of solutions. One solution is to use the sticky session, like load balancer with the sticky sessions. But what I feel like, what I'm suggesting in this slide is use a shared distributed memory. Because like I prefer to develop AI agents in a stateless way. So what we doing here is we use shared distributed memory. So AI agents share this store as their memory. So when you ask something, it go to the load balancer and it go to any replica, and it will update this share store. And when the second request come, it will go to another replica, but it also access the same share store. So the memory is inside the shared store, so there's no confusion happen. Always AI agents go to the share store and read it and then give the response accordingly. So this will work. So if you're developing AI agent, like I prefer to say you try to use it as stateless as possible. Like otherwise you will get problems like that. Okay. The third one, this is a very complex problem actually. I think a lot of researchers are also going about this topic, context management. So when we are dealing with customers, what we experience is when to develop an AI agent, so we are developing an AI agent for a company. Our customer is also a company, right? It may be insurance company or hotel or some company. So for the AI agent to work properly on that company, AI agent has to know the history of the company, policies of the company, customers, user data, user preferences, the structure of the company. So there are a lot of things AI agent should know to work, right? Otherwise it cannot work properly. So there are a lot of context, actually massive context, when we are dealing with the enterprise AI agents. So this context management is very important. Otherwise our AI agent continuously give the wrong answers. Wrong means so it will lead to a disaster. So the first, I list down some problems. There are a lot of problems. So the first problem is context overflow. You may know that LLM models, that means AI agents, has a context length, maximum context length window. As example, 200,000 tokens, something like that. So that is the maximum context that LLM model can handle at a time. So we need to put all the things I said before into that maximum context length window. So it's a challenge, right? So that is a one challenge, and also there's a order sensitivity in LLM models. Some models, like if you give some informations in a 1, 2, 3, 4, 5 order, some models may take the most recent one, the 5th one, as a high priority one, the recent one. So that is also a problem can happen. And also this conflicting sources thing, this is more practical one, the conflicting sources one. I will tell you a story. So when we are developing for a agent for a customer, what happens is they have 2 or 3 different sources, systems that contains user data. sometimes the email of one user is different in each systems. So that is a conflicting, right? That is can happen in the real world. In the demo it cannot happen, but in the real world it happen. And also incomplete context. Nothing is complete. So in the real world, incomplete contexts are also there. And also recency bias, like I said previously. So to mitigate those issues, to overcome those issues, we need to do some best practices while we are developing the AI agents. One thing we can do is smart retrieval. Like we do not provide the whole context to the LLM model. For the AI agent, what we do is, based on the user query or the user question, we smartly retrieve the relevant context. As example, if the user query is related to the HR policies, we only gather the context related to the HR policies. We omit the some user preferences or something like that. So that is one way. And the second thing we can do is context ranking and prioritization. So all the context does not have the same priority, right? So we can prioritize them by relevance, recency, source authority, like that. And also this conflict resolution layer is also a very important thing we need to do. Like I said, it is happening in the real world. Conflicts occurs. So we need to say LLM, this is the source of truth. If you have a conflict, you need to watch, you need to search in this system, or you can ask from the human, something like that. You need to implement this conflict resolution layer. And also the fourth one is context validation pipeline. We can implement it as a pre-processing layer that run on weekly or monthly, or it's a one way to do that. There are a lot of ways to do that. So what I mean by context validation pipeline is something like it run on weekly and it will remove the invalidate context, and it will check the conflicts about the context and like inform to the user, something like that. This is a programmatic thing. What I'm suggesting is a programmatic thing, but the context validation can implement in several ways. But it is important to have such a pipeline in your real world production. And also, instead of treating all the context as the same, you can put it as a hierarchical context architecture. Like you can divide it into three parts, many parts, but in this slide I'm suggesting three: foundation knowledge, session specific context, real-time data. Like session specific context means if the context related to the session 1 is not related to the session 2, something like that. So it will not mess up the context between sessions. So that is the thing about the context. In the fourth problem, we are talking about something different. So this is also we experienced when we developing things. In here, what happened is, like when we develop AI agents for the production system for the customers, they need our AI agent to do almost all the things. Like in theory, AI agents or like a sub agent or something like that need to do only one specific task or few tasks. But in real world, they expected us to do lot of things. They expected us to do something like support ticket handling, something like policy handling. There are various things they need to do. So if we add tools, like if we add functions, tools to do all these tasks to our core AI agent, it will look like this. There are a lot of tools around our AI agent. So what will this lead to? This will lead to performance bottleneck, because if the AI agent have a lot of tools, and if a user query or a user prompt came into the AI agent, it need to figure it out what tools it need to use to answer this user query, right? So if there is a lot of number of tools, it will take time, and it will affect for the latency and the slow response, those stuff. So one tool is better. What I mean is not I cannot tell exact number, but what I can tell is, if you have a massive number of tools, this issue can be happen. So better to architect in a good way to avoid this issue. Let's see how we can do that. There are two solutions. What I am suggesting, there can be more solutions, but what I see is these two solutions we can avoid that problem with these two solutions. The first solution is context-aware tool selection. This is something interesting. So in here what we do is, instead of giving all the tools to the LLM, all the tools to the AI agent, what we do is we select the most relevant tools according to the user's query and give that to the AI agent. So AI agent does not see all the tools at once. It only see the tools that are related to the user query. So that I mean by the dynamically feed only the relevant tools. So this was now you can test this with our Balda integrator. BI agent have this facility, and also we are using that when we are developing customer related stuff. And also the second one is the most famous one, hierarchical sub-agents. This can also be done. What happens is in here, instead of having a one monolithic agent, you divide the task into few subtasks, something like HR policy related tasks, something like support related tasks. So you divide that into few subtasks and develop sub-agents for each task. And you provide an orchestrate agent to delegate the task. So when user queries come into here, it will go to the orchestrate agent. Orchestrate agent will choose the relevant sub-agent to handle that query. If there is no sub-agent, orchestrate agent may handle that. It is depend on your implementation. So this is also possible, and the context-aware tool selection is possible. So what to select is depend on the context and depend on your implementation. So let's move on to the fifth problem. This is the most critical one. This is really critical. The human safeguard problem. Assume you are developing a bank, you are developing an AI agent related to bank. Open banking guys are here, right? So assuming you are developing an AI agent for a bank and it updates the user's account balance or something like that. It is very dangerous, right? It is risky because for these kind of things, it's not just about the bank statements. What I'm like to say is, if your AI agent update or changes the state of your system, I would rather recommend go through a human in the loop safeguard. So in what happened in here is, AI create the proposal, AI creates what to do with what parameters and how to do that, and it present it to the human, and human need to approve that, then AI agent execute that. So I think this is really critical when you are developing AI agents. So remember that, do not let the AI to do risky things. Do it with human safeguard. This is not about untrusting the AI, but it's about architecturing for safe. Okay, there are some few more lessons I would like to cover. I will cover this in very brief manner with the interest of time. So there's another one is knowledge cutoff problem. I think you all know about this. LLM models trained for up to some specific date, right? After that date, LLM models does not have the knowledge, you know, right? But I will tell you what I experienced with this. I experienced really different thing. So in one customer related task, I develop AI agent and I asked the AI agent, show me the errors that happened on yesterday. And what happened is AI agent execute the query and give me some errors. Then when I check the dates of that errors, it was 2 years ago. Like what happened is, it interpreted the yesterday as 2 years ago. It interpreted the yesterday as the cutoff date, like 1 day before the cutoff date. So that is that's I think real world example of having this issue. So we need to mitigate that issue. We cannot say our customers that AI does not know after that, right? One possible solution is RAG. We can give a data set, or relevant data sources, documents to AI agent using a RAG pipeline, something like that. And also second one is dangerous problem. It's a dangerous problem, hallucination problem. Hallucination means if LLMs can make up facts, and it is really convincing. And like if we haven't any domain specific knowledge about that, we will believe that it is correct. So it is a very dangerous one. So we need to avoid that also when we are developing the production systems. We can use something like RAG for that also to avoid this hallucination problem by giving trusted sources into the LLMs. Okay, there's another problem, the black box problem. So I name it as black box problem. What happened is, if there is unexpected output came here, we don't know what happened in the inside. So we cannot see what happened in the inside. So for mitigate that problem, we need to implement tracing and observability supports for our AI agents. And like when we are giving solutions to the customers, we need to give that observability and tracing supports also. And the good thing is, in our Balra integrated WSO2 technology, we have all that support now. So okay, finally, with the all hard lessons, so we was able to build, like after learning all the hard lessons, we will able to build this bridge more strongly, and we can move our customer systems from AI demos to enterprises productions without any issue or errors. So actually we learned this in hard way. That's what I shared, our experiences and the lessons we learned with you. So